Welcome back to my channel. This is the chapter is Trigonometry for Standard 10. It's part 6. Now we are going to do some problems related using the identities. So prove that this expression is equal to minus sine squared a. So we'll start with LHS. LHS is equal to, now sine 90 minus a is cos a. So minus 1 plus sin a into cos a by cot 90 minus a is tan a is equal to minus 1 plus, now minus 1 okay, I'm sorry, the question here is this is only till here. That's why I was not getting the answer. Yeah. So this is tan a. So this is equal to, tan a can be written as minus 1 plus sin a cos a by tan a is sin a by cos a. So sin a, then the cos will go to the numerator. So this is equal to minus 1 plus sin and sin will get cancelled and you're left with cos squared a. So minus 1 plus cos squared a. So this is equal to, we know sin squared a plus cos squared a is equal to 1. This is identity that we are using here. So cos squared a minus 1 will become minus sin squared a equal to RHS. Here cot theta minus cosecant theta the whole squared is equal to 1 minus cos theta by 1 plus cos theta you have to prove. So we'll again start with LHS. So here your answer is cos. Here it is cot and cosec is given. So you have to convert it into sin and cos. So cos theta by sin theta minus cosecant theta is 1 by sin theta the whole squared. That is equal to cos theta minus 1 by sin theta the whole squared. So this is equal to squaring the numerator, cos squared theta plus 1 minus 2. Yeah, no need of that. You don't have to expand it. We can write cos theta minus 1 as 1 minus cos theta because you are going to square it and the denominator is sin squared theta. So this is 1 minus cos theta into 1 minus cos theta, while sin squared theta is 1 minus cos squared theta. One minus cos squared theta is a squared minus b squared is equal to a plus b into a minus b. So you will write 1 minus cos theta into 1 minus cos theta by the denominator as 1 plus cos theta into 1 minus cos theta. Now you can cut these two. So now you are left with 1 minus cos theta by 1 plus cos theta. So equal to RHS. Now here sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. So here if you see, the numerator sin theta is common and the denominator cos theta is common. So we'll take out sin theta out. So 1 minus 2 sin square theta. And here cos theta into 2 cos square theta minus 1. Now 1 minus 2 sin square theta can be written as 1 minus 2 sin square theta is equal to 1 minus sin square theta minus sin square theta. 1 minus sin square theta is cos square theta minus sin square theta. And 2 cos square theta minus 1 can be written as cos square theta plus cos square theta minus 1, or cos square theta minus of 1 minus cos square theta. So this becomes cos square theta minus sin square theta. Substitute it here, we'll get sin theta by cos theta will become tan theta. So we can straight away write it tan theta. Then 1 minus 2 sin square theta has become cos square theta minus sin square theta by 2 cos square theta minus 1 has become again cos square theta minus sin square theta. Now you can cancel this and you are left with tan theta equal to RHS. This you can do it in this side and then substitute it. Now it is cosecant square theta minus tan squared 90 minus theta. So here see your right RHS, it is sine. So we have to convert the cosecant into sine. So 1 by sine square theta. So when you do, you should always keep checking what you have to get it in RHS. Accordingly, you have to keep converting till you get your RHS. It's all come by practice. So you have lot of problems where you can practice and be thorough. So tan 90 minus theta is cot theta. So this is equal to 1 by sin square theta minus cot theta is cos by sin. So cos square theta by sin square theta. So equal to sin square theta 1 minus cos square theta equal to sin square theta by sin square theta equal to 1. Now we will take the RHS and then simplify. So in some cases you can do separately LHS and RHS and then you can say it is equal. So now sin squared theta plus sin 90 minus theta becomes cos theta. So cos squared theta. So equal to 1. So LHS is equal to RHS. Cosecant theta plus cot theta the whole square is equal to secant theta plus 1 by secant theta minus 1. So here again we will start with LHS. 1 by sin theta plus cot is cos by sin So this is equal to a similar sum we did earlier, the same method. So it is 1 plus cos theta the whole squared by sin squared theta. Sin squared theta can be written as, or write it down, sin squared theta equal to 1 plus cos theta the whole squared by 1 minus cos squared theta. So you will be left with 1 plus cos theta by, this is 1 plus cos theta into 1 minus cos theta. So 1 plus cos theta get cancelled and you are left with 1 minus cos theta. This is what you proved in one of the earlier problems. Now your answer is secant theta plus 1. So we will divide the numerator and denominator by cos theta. So 1 plus cos theta by cos theta, the whole divided by 1 minus cos theta by cos theta. So it becomes 1 by cos theta plus 1 by 1 by cos theta minus 1. So this is secant theta plus 1 by secant theta minus 1 equal to RHS. Now here 1 plus cos 90 minus theta. So we'll start with again LHS. Cos 90 minus theta will become sin theta minus 1 by 1 minus sin theta. So taking the LCM, we'll get 1 minus sin squared theta. 1 plus sin theta into 1 minus sin theta becomes 1 minus sin squared theta. Your numerator will be 1 minus sin theta minus of 1 plus sin theta. So this is minus 2 sin theta by cos squared theta. 1 minus sin squared theta is cos squared theta. So minus 2 sin theta by cos theta into 1 by cos theta. Cos squared theta we have split it and written as cos theta and cos theta. So minus 2 tan theta into secant theta. So now your answer is cosecant 90 minus theta. So you can write this again as 2 tan theta into cosecant 90 minus theta. Equal to RHS. Hope you find these problems easy. So keep practicing. We will do a lot of problems and little more difficult problems too. So unless you practice and become familiar with the identities and all the ratios, then otherwise you will find it very difficult. So see you with more problems in my next video. So keep practicing and keep watching. Have a nice day. Bye.